Okay, hello everyone in a new video. In this one we are going to start part 1 of chapter 8, which is the chapter of mechanical actions and the third unit of mechanics. Now in this chapter we are going to introduce the vector, which is essential to describe the forces, and the scientist behind the introduction of the vectors is Sir Isaac Newton, and this comes from the fact that as the stories claim for sure that he was sitting under the tree under which he has observed an apple undergoing a vertically downward motion. So let me start by the first section, which is section number 1, the force. And let me start by the direct definition. And then the force is a mechanical action exerted by a body on another. So this is the physical definition of the force. Now let's refer to the mathematical definition that we will start discussing, which is given by the force is represented by a vector F. Now in the first part of this chapter we will stress on the mathematical definition, and which is given by the vector. Then we will discuss the classification of a force and its properties, which allows us then to introduce different forces that are the forces of nature, and perform a concrete map between the mathematical and the physical definition. Now, in order to describe the properties of a vector or a force, first we need to classify a force. Then let me write section number 2, the classification of forces. There are two categories. Then whenever we are talking about the type, we mean the category, and we mean as well as the classification of forces. And they are given by then the first one is known as the contact forces. Then some examples of contact forces are the normal reaction, another example, upthrust force, and actually this is an unend list. We can see also the tension force. We can say the muscular force. Also the motive force, which is the force that causes motion, and this is known also the traction force. And the list goes on and on. Now, as for the other type of forces is given by the acting at a distance. And they are only given by the weight, which is the gravitational force. We have the electric force. And we have also the magnetic force. So the thing is that it's difficult to limit this list under the classification of the contact force. So because I have mentioned this is a non-ending list, what we will do is that we will only memorize and understand that the only three forces that act at a distance are given by the weight, the electric, and the magnetic, and by this all other forces are classified as contact forces. So let me give an example on that. Suppose they have introduced a new force which is said to be X force. We don't know what is the type of this force, and we are asked to classify this force. We ask ourselves, is it weight, electric, or magnetic? No, it's not one of these, otherwise it would have been named like weight, electric, or magnetic. For this reason, this is classified as a contact force. Okay, so what about, for example, the motive force? It's not weight, nor electric, nor magnetic, so it's classified as a contact force. So we will memorize that the only three forces acting at a distance are the weight, the electric, the magnetic, and all other forces are classified as contact forces. Now this classification is important, as we shall see later, and from this let me move on to the next section, which is section 3, characteristics of a force. And let me say the properties of the force are given by point of application, the line of action, the direction, and the magnitude. And this order is given by the Pildum. So usually we list these properties by the following order: the Pildum, in which P represents the point of application, L for line of action, D direction, and M the magnitude. Let me start by subsection 3.1, which is the point of application. And let me consider the following line of action along which the force is applied. So let me say that this is the force like this. Its name is given by F. This is the tail of the vector, this is the head of the vector, and let me give the tail of the vector the point A. And what does the point of application represent? It is the point where the force is applied. In this case, the force F is applied at the point A, then the point of application in this case is given by the point A. And now for subsection 3.2, let me say the line of action. The line of action is given by, it is the line along which the force is applied. And we have the following choices. Then choice number 1 is the vertical. Choice number 2 is the horizontal. And the final choice is given by oblique along a straight line. This is given by the vertical, this is given by the horizontal, and the oblique, let me write them here. This is the vertical, this is the horizontal. The oblique can be either like this or like this. So, as it's being mentioned here, it is the line along which the force is applied. So, in this case, it is oblique along a straight line. And now let me move to 3.3, which is given by the direction. Now, why the direction is essential in this case? Because for the following line of action, we may have two directions, either like this or like this. So it is important to distinguish between directions, and let me here say it is the direction along which the force is applied. And we have the following choices. And let me represent the following diagram. So let me say that this is U, this is UR, R, DR, D, DL, L, and UL. And here on the other side, let me say what does each direction represent. Then U is for upward. As you can notice that in this case, this force is pointing upward. Now in the second case, UR stands for upward to the left. Sorry, upward to the right. UR stands for upward to the right. Now in the third case, R alone stands for right, which is this one. And DR is for downward to the right. So whenever we are describing directions, we always start by the vertical, then the horizontal. So in this case, we move down, then to the right. Now fifth choice is given by downward. And choice number 6 is given by downward to the left. And the 7th choice is given by the left. And the final choice, which is 8, UL, is given by upward to the left. Then in this case, the direction of the force F, okay, the line of action is oblique, the direction will be upward to the right. And now the final property, which is essential also to describe a vector, which is a force, the magnitude. Then let me write subsection 3.4, the magnitude. This is N. So what does the magnitude represent? The magnitude of the force gives us information of how much strong is the force, how the force is, it's the same. And the SI unit of the magnitude is in Newton. And its symbol is given by N. So how can one, for example, determine the magnitude? The magnitude of the force is measured using a spring balance. This is also known as the dynamometer. Or via a certain method, as we shall see later. So these are the 4 properties of the force given by the point of application, the line of action, the direction, and the magnitude. And now, as for the characteristics, the classification of the force, which is acting at a distance or contact force. Now, later on, we will see that it will play a crucial role in specifying the point of application. But here also, let me say that the line of action is represented by this dotted line. Okay, so now we have the direction. This is the direction, which is the pointing of the arrow. The pointing of the arrow represents the direction. Now point A represents the point of application. Now as for the magnitude is not represented here, but it reflects the length of this vector, which is this. Now, so the length of the vector is related to the magnitude, and this is done by the representation of the vector, which is the title of this section, section number 4, representing a force. We have the first choice that is given by with a scale. And here let's recall from grade 8 that represent, it means that we need to draw. Whenever we say represent a force, this means that we are drawing a force. Then the force F, which is given by the mathematical definition, the vector, is represented by a vector taking into consideration the properties that are given by the buildup of the force. And now a convenient scale is given in order to represent the magnitude of the force. And 1 centimeters must represent the unit of length. Now I will clarify what is meant by this. Of the vector properties. So 1 centimeter of the length of the vector represents a certain number of newtons. Now this statement here is extremely important. Now I will refer to, but let me say also the magnitude is determined using rule 3. Rule of 3, and here the rule of 3 is given by the crisscross. So let me now start by specifying some examples, and let me say here are some good examples of different scales. Let me give example A, in which 1 centimeters corresponds to, say for example, 3 newtons. So here I have said that 1 centimeter of the length of the vector represents a number of newton. So this 1 centimeters is a scale. So here, for example, if we have 2 centimeters corresponds to 3 newtons, this is not a scale anymore, because the scale is based on the fact that this must be a unit of length, which is 1 and not 2. Okay, so this is a good example of a scale. Now, I repeat, 1 centimeters of the length of the vector represents a number of Newton. So this represents will allows us to calculate the length of the vector. Now, given 3 newtons corresponding to 1 centimeters, what about 6 newtons corresponds to how much? So the rule of 3 here that I have stated before is that we multiply 6 by 1 and divide it by 3. So 6 multiplied by 1 divided by 3, which is equal to 2 centimeters. This represents the length of the vector, worth 6 newtons, using this scale. Now another scale given by B, for example, another example. So 1 centimeters corresponding to 6 newtons. As you can see that this must be always fixed to 1 centimeters. We are allowed to change the magnitude. This which makes the scale a convenient scale from problem to another depending on the magnitude of the forces that we are representing. Another good scale is given by 1 centimeters corresponding to 10 newtons. So this is also a scale independent of this number. What is important in that this must be a unit of length, which is 1 centimeters. So whenever we are representing a force with a scale, then we should determine the length of the vector that we are representing. Now another representation is given by without a scale, which is 4.2. Then without a scale, then the force F is represented taking into consideration just the PLD without the M, excluding M. So here M is excluded, the PLD properties. Then we are not interested in the length of the vector. So in this case, the length of the vector is not important, which represents the magnitude. So we just represent the force F according to the PLD properties. In this case, whenever we are representing a force with a scale, we need to consider the PLD and M. And now let's solve the following exercises as a direct application on what we have explained so far. In exercise number 1, they are telling me, given the force, the following diagram, list the properties of all the given forces, take into consideration the following scale. So we have 1, 2, 3, 4, 5 forces that we are interested in listing their properties. Let me start by the weight W. And we are interested in listing its properties that are given by the building. Standing for the point of application, line of action, direction, and the magnitude. So in this case, the point of application of W is A. What about the line of action? So we have vertical, horizontal, oblique. In this case, it is vertical. What about the direction? The direction in this case is given by downward, indicated by the arrow of the vector. And the magnitude, which is listed here, is given by 3 newtons. Now, as you can see here, we are discussing vectors without considering the physical effect behind these vectors, but we know later that, or from grade 8, that this vector W will be mapped into the weight. And now let me move to the other force, which is the force F1. And let me say the point of application. And as you can notice that I have listed these properties in the following order: point of application, line of action, direction, and the magnitude. Without exception, the properties of the force F1 will be listed P, L, D, and M. Now the point of application of F1 is given by the point A. The line of action, we have three choices. This is the vertical, this is the horizontal, and these represent the oblique. Now in this case, the line of action of F1 is oblique. What about the direction? And this is done by referring to the arrow indicated on the head of the vector. Notice that in this case it's pointing upward to the right. We always start by the vertical, moving to the horizontal, so it is upward to the right. Now as for the magnitude, here we don't have the magnitude of the force F1. We have the length because it is represented in centimeters, and we know that in order to move from the length to the magnitude and from the magnitude to the length, this is done by the connection between both, which is given by the scale. Let me here say that the magnitude, and leave a blank space, knowing that each 1 centimeters corresponds to 3 newtons. What about 4 centimeters? It corresponds to how much? We place it under centimeters, and here we leave an empty space. Now using the rule of 3, which is the crisscross, 4 multiplied by 3 divided by 1, this is equal to 12. This is 12 under the instead of the question mark, which is under the newtons, and it is expressed in newtons. So the magnitude is given by 12 newtons. Now these are the properties of the force F1. Let me move to the properties of the force F2. By the point of application. And this is given by the point B. As for the line of action, it's given by horizontal. The direction here is given by left. And as for the magnitude, no need for any calculation because the magnitude is already represented on the force itself, which is given by 1 newtons. Now it's left to list the properties of the other forces given by the tension T and the force F3. Let me start by the force F3. So the point of application, and recall that I'm always listing the properties in the following order. So the point of applications is also given by B. The line of action, in this case it's not vertical nor horizontal, is given by oblique. We can say oblique along a straight line. Now the direction, the arrow is pointing downward to the right. And as for the magnitude, here we have the length of the vector, which is 2.5 centimeters. We are interested in the magnitudes, which is expressed in newtons, and this is done by considering the connection, which is the scale. 2.5 centimeters is placed here, and here we leave an empty space. Then 2.5 multiplied by 3 divided by 1, This is equal to 7.5 in newtons. Then the magnitude of the force F3 is given by 7.5 in newtons. It is left to list the properties of the tension T. Sorry, not tension. The force T, because yet we are discussing the mathematical properties and not the physical. So the point of application. The point of application in this case is given by the point B. The line of action. In this case, it's given by vertical. Now the direction. The direction in this case is given by upward. As for the magnitude, now here the length of the vector is given and not the magnitude, and in order to determine the magnitude we need to use the scale. If each 1 centimeters corresponds to 3 newtons, what about 3 centimeters? It corresponds to how much? Then if we crisscross 3 multiplied by 3 divided by 1, this is equal to 9 newtons. And as you can notice that I have listed them in the following order, which is the builder. Now let me move to the next exercise, which is exercise number 2. They are telling me represent without a scale the forces F1 and F2 with the following properties. So without a scale, it means that we are not interested in the length of the vector, which represents the magnitude, and we are only interested in the P, L, and D. And let me start by the force F1. They are telling me the point of application is A. So directly I place here a point A, which represents the point of application of the force. The line of action is vertical. Then the force F will be either represented like this or like this. And they are telling me downward. I repeat, the length of the vector is not important. So this is the force F. We can represent the force F by 3 divisions, 4 divisions, 5 divisions. It's not important. Now in number 2, they are telling me the name of this force is F2, represented at the point B. And it is acting, so the line of action is horizontal and the direction is to the left. So it's acting horizontally to the left. And the length of this force is not important. Then in this case, we say that the force F1 is acting on the point A vertically downward. The force F2 is acting on the point B vertically, horizontally to the left. And now as for the next exercise, which is exercise number 3, they are telling me represent the forces F1 and F2 with the following properties. The point of application is the point A. And they are telling me the line of action is horizontal, the direction is to the right. So the force F1 will be acting something like this. But they are telling me that the magnitude is 4 newtons and we need to consider the following scale. So now in order to represent the vector, we are interested in determining its length. But we have the magnitude. The length can be determined upon the following scale. If each 1 centimeters corresponds to 2 newtons, then the 4 newtons corresponds to how many centimeters? Now if we crisscross 4 multiplied by 1 divided by 2, then 4 multiplied by 1 divided by 2, this is equal to 2 centimeters. Then the length of this vector is given by 2 centimeters. Then at the point A, there will be a force F1 acting horizontally to the right of length 2 newton, of length 2 centimeters. What does this mean? That the strength or the magnitude of this force is given by 4 newtons. So the length of this vector is given by 2 centimeters worth 4 newtons. And here the division that I have represented, it means that each division is given by 1 centimeters and 1 centimeter is adding up to 2 centimeters. This is it for part 1. Now the part 2 of this exercise, They are telling me point of application of the force F2 is the point B. And the force is acting vertically upward, which means that the line of action is vertical, the direction of is upward. So it is acting something like this. But we need to take into consideration the magnitude, because they are telling me consider the scale 2 centimeters corresponding to 6 newtons. Now 2 centimeters corresponding to 6 newtons is not a scale, because this is not represented in unit of length, which is 1. Let's convert it to scale. Then in this case, dividing both sides by this number, which is 2, then the scale that you are interested in is given by 1 centimeter corresponds to 3 newtons. Now 9 newtons corresponds to how many centimeters? Then 1 multiplied by 9 divided by 3, this is equal to 3, and this is centimeters. So the length of this vector is given by 3 centimeters. Then at the point B, there will be a force given by the force F2 acting vertically upward. This is F2 acting vertically upward. The length of this vector is 3 centimeters. Notice that here each division corresponds to 1 centimeters. For this reason, I have placed a dash worth 9 newtons. So that's it for me in this video, guys. In the next part, we will consider the physical application of the force and solve some exercises.